Underground mining was significant in Britain and many other countries. Coal was abundant in England and became the common form of energy initially for heating and metallurgy. Unfortunately, these mines also flooded, and removal by bucket slowed the work, not to mention the possibility of drowning. Scientists determined that the atmosphere had weight and steam could be condensed to form a vacuum. Trained as a military engineer, Thomas Savery patented his steam-powered pump in 1698 to raise the water and drain the mines. Without a piston, it was inefficient and used immense amounts of coal, but not a problem at a coal mine. However, the Savery pump could lift water only about 30 feet. Despite the problems, this was the start of the steam age. Given Savery's patent, Thomas Newcomen had to work with him as a partner. The result was the improved Newcomen pump in 1712, marketed under Savery's patent. His pumps were bigger and cost more. Newcomen's steam engine added a piston, an idea from a French scientist, a cylinder with a piston inside. Water was placed in the cylinder below the piston and heated. The steam would push the piston up. When the cylinder was cooled, the piston came down. James Watt was a Scottish inventor and instrument maker good at fixing mechanical machines. He was asked to repair a Newcomen engine. Watt discovered that the engine used 4 times as much water as needed because the cylinder was constantly changing temperature. His solution was to condense the steam somewhere else, the boiler. The result was the Watt steam engine. Figuring out the problem was one thing, making a viable machine to sell was another. Watt developed a workable design, receiving a patent extension in 1775, but struggled to build a full-scale engine. That required more capital than he could raise. The solution was a partnership with Matthew Boulton, owner of Soho Manufacturing near Birmingham. With the help of John Wilkinson, Boulton and Watt had their revolutionary steam engine by 1776. Most early engines were manufactured by others using their design and were mainly used for pumping water out of mines. Boulton handled the business side. Watt continued to improve the engine for efficiency, quicker manufacturing, and easier installation. Watt modified it to provide rotary motion for driving machinery, allowing factories to be located away from rivers. He retired in 1800 when his major patent expired. Watt was typical, requiring a rich partner to finance the new business. Either the inventor had the funds to build and innovate, relied on family, or found partners to finance operations. Banks were latecomers, like the monopoly bankers of the Gilded Age, such as J.P. Morgan. Joint stock companies were used primarily for major projects, such as canals. Britain came to dominate iron and steel in the 18th century, pulling ahead of France and Germany. They used coal, then used coke as a purified form of coal. The reverberating furnace melted the iron, and the puddling process stirred the molten metal into wrought iron. John Wilkerson was a major manufacturer, including casting solid naval cannons, which had the advantage of not exploding. Benjamin Huntsman created crucible steel in the 1740s, remelting high-quality steel into clay pots, crucibles. Lighter, increasingly efficient steam engines became power sources for textiles, blast furnace blowers, and lathes. Bigger factories meant bigger machines at higher speeds. As historian Robert Allen stated, the British achieved a point of critical mass at which understanding expanded exponentially and inventions, technologies, and accumulated lore cohered into an irresistible surge. The Corliss engine was patented by the American George Henry Corliss in 1849, a four-valve counterflow engine with separate valves for intake and exhaust, with an automatic variable steam cutoff. This efficient machine used 30% less steam while providing relatively uniform speed, especially useful for certain types of factories like cotton spinning. Farming was a limited market for steam engines. An early use was engines built in barns to drive threshing machines and for drainage pumps. Later use was for portable engines taken from field to field, especially after 1850, when engines were used for plowing. They were used as steam-powered tractors capable of heavy loads. High-pressure steam engines were put underside and turned into locomotives. That major improvement in land transportation next time on Food History and Mystery.